Get on your job, tell them haters get on your job, hey, motivation, haters better get on your job, tell them haters get on your job, motivation, sucker, get on your job, if you hate, get on your job, you can look me in my eyes, see I'm ready for whatever, anything don't kill me, make me better, I ain't dead, you can take the fame and the cheddar, and the game and the deal, I'm still a go-getter.
Alright, before we start getting right into these notes, let's go ahead and start with this first square here. So we know looking at something that's parallel. So let's first graph these two lines. So we're going to start at our y-intercept for the first one. And then go up 2 over 1. Up 2 over 1. And that's our first line. Alright, let's do the same for the second. I'm going to graph that one also. But now we're going to start at -3. Up 2 over 1. Up 2 over 1. So on and so forth. Alright, this next part asks us, what do we notice? So a couple things you should notice is, one, that our slopes are the same. So they both have slopes of 2, and the lines do not cross, or let's say intersect. It's the same as cross. Kind of like an intersection, the lines don't cross. So because the slopes are the same, the lines don't ever cross when they never intersect. That makes these two lines parallel. Alright, lines that are parallel have the same slope. So let's look at this right here. What is the slope of a line that is parallel to y equals 3x plus 5? Well, the slope is 3, so a line parallel to that would have a slope of 3. Same thing here, we go in and put our 1 because there wasn't a number in front of x. So the slope of a line parallel will be -1. Here it'd be 1/2. Again, putting our 1, be 1, and -3/4. Alright. So one thing we do know, if we're writing an equation to a line that's parallel and we're given the equation of the other line, we at least know what the slope is. So like right here, writing the equation of a line parallel to y equals 3x plus 5, but passes through the point 1, 4. So we already know that it's going to have the same slope, so we at least know that the slope equals 3. We need it to pass through this point. So this is like when we're giving the point and a slope. So remember, point slope form. Is y minus y1 equals m times x minus x1. So though we're not explicitly given the slope, they don't just tell us what the slope is, because we know that the line is parallel, we know that it's going to have the same slope as the line that's given. So we know our slope is 3. Now we take our m, this is going to be x1, y1, and we just plug those parts in. So it's 1 minus 4 equals our slope times x minus 1. Then we distribute. So before we distribute, this was a question that was tripping a lot of people up. This is in point slope form. As long as there's no double negatives or anything, this is in point slope form. Now to get it into slope intercept form, we just get y by itself. So we're going to distribute the 3. And then add 4. Boom. So this is our equation. All right, and then if it asks us to put it into standard form, remember you want to get x and y on the same side. Right over here, so you have negative 3x plus y equals 1. And remember, sometimes you're going to see it in proper standard form where this negative can't be in the front, so you just change the sign of everything. You do have to understand that this is the same equation. Now we just change the sign of everything. So let's try the next one. Put a 1 in front, passes through negative 2, 6, and this is the equation. So since these are parallel, they are going to have the same slope. The slope of this equation is negative 1. So m equals negative 1. And we have x1 and y1 here. So y minus 6 equals negative 1 times x minus negative 2. Please be careful when you're given a negative number and plug it in as a negative number. Common mistake, some of us will put x minus 2 when it's x minus whatever that x value is, y minus whatever that y value is. Alright, put it in exactly how it is. So then we solve. Now, since there is a double negative, this would actually be point slope form. Not the first one, but once we get rid of that double negative, this would be point slope form. Alright, and then we do the same thing as we did before. X minus 2 at 6. Y equals negative 1x plus 4. Now, you might see it as y equals negative x plus 4, because remember, you don't have to write that 1. Alright? It's not always going to be there. Then to get it into standard form, so this is point slope, slope intercept. And this is standard. Standard insurance. Alright, and this last one on parallel lines. Our slope, again, the number in front of x, the coefficient of x, is 1/2. And it passes through 0, 5. So this is x1, y1. Y equals 1/2. What am I doing? Shoot, tripping. Y minus 5 equals 1/2 times x minus 0. Then we solve in, and we're going to distribute that 1/2. Got 1/2 x minus 0. Plus minus 0 doesn't matter, but let's do it, right? When we add 5 plus 5, we still alive. Y equals 1/2 x plus 5. Now, notice I could have saved time by noticing that this x is 0. When your x is 0, the y value is going to be a y-intercept. Because remember, the y-intercept is what y equals when x is 0. All right, so this is my b right here, because that's the y-intercept. So I could just simply write out y equals 1/2 x plus 5. Boom. Didn't have to do the intermediate stuff. All right. Now to get it into standard form, just a quick review. We're going to put them in standard form on all these just so we can practice putting it in standard form. So you move 1/2 x over. It's got negative 1/2 x plus y equals 5. Now remember, you shouldn't have a negative nor a fraction. So let me move this over here. Try to keep it all in the same problem. So negative 1/2 x plus y equals 5. So remember, to get rid of a fraction, you multiply by the denominator. Alright, so negative 2 times negative 1/2, that's just 1x. Negative 2 times y is negative 2y. Negative 2 times 5, so remember, distribute it to each term. Negative 10. Boom. So that's standard form right there. But as long as you can get this, you're good. But you do need to know how to get it in standard form. So on the other side, we have perpendicular. So let's again graph these two equations. Let's use some other colors. Let's use some purple. Let's use some vibranium. So this is going to be this one. It's going to be that one. So the graph, boom, start the y-intercept, which is 1. This is negative, so we're going to go down 1 and over 2. Down 1 and over 2. And that's a nice straight line. Whoop, whoop. And then we graph the odd. 1, 2, 3. Up 2 over 1. Up 2 over 1. I'm going to grab that too. We's going to grab that too. Alright, so what do we notice here? Alright. So it says these slopes have, stand up real quick. Come on, light. There we go. Alright, what I do know, as the lines intersect, at a right angle. Alright, so that's the definition of perpendicular, anything that intersects at a right angle. Alright, a 90-degree angle. The slopes have I'm trying to figure out what those are here. I know it's not in half. So the slopes are opposite and reciprocal. Alright, what does that mean? That's what goes there. Okay. Have opposite signs. And are reciprocal. So, opposite signs. This one is negative. This one is positive. Alright. Negative 1/2, positive 2. And remember, reciprocal is just when we flip a fraction. So, reciprocal is best described with an example. So if I have 4/5, the reciprocal would be 5/4. Now with whole numbers, you have to remember we can put those over 1. And so negative 1 over 2, flip it and reverse it. So you do two things. You change the sign and flip it. So positive 2 over 1, which is what we have right here, which makes it reciprocal and makes it perpendicular. So remember, perpendicular, lines that intersect at a right angle. So I'm looking at these problems. What is the slope of a line perpendicular to 3x plus 5? So that's a positive, so we know it's going to be negative. Then we put this over 1, so it'll be negative 1/3. Put a negative here. Put over 1, so it'll be a positive 1 over 1, or just a 1. Opposite of positive 1/2, so that'll be negative 2 over 1, which is just negative 2. Again, put 1 here. Negative 1 over 1, which is negative 1. And make this positive. So there's going to be a positive 4 over 3. Alright. So the same way, in the parallel lines, we weren't given the slope, but since we know that it's perpendicular, we know that the slope of the line we're given, the new line, is going to be opposite and reciprocal. So since the slope here is 3, our new slope is going to be negative and the reciprocal of that number. Alright, so, and we're given this point, x1, y1, and we plug those in the same way we did in parallel lines. So y minus 4 equals negative 1/3 times x minus 1. Then we distribute that thing. Negative 1/3 x plus 1/3, because you have a negative times a negative. Then add 4. Now it keeps running out of space. Y equals 1/3 x. That'll be 12 over 3. So it'll be plus 13 over 3. So we got to make this 4 have a common denominator. So 4 equals something over 3. 3 times 4 is 12. That's where we get 12 from. So 12 over 3 is the same as 4. Alright, another one. Slope here is negative 1. So the slope of my new line is going to be a positive 1. And it passes through negative 2, 6. So y minus 6 equals 1 times x minus negative 2. Remember, this becomes plus. And then multiply my 1, add 6 to both sides. Y equals x plus 8. And the last one. Y equals 1/2 x plus 5 passes through 0, 5. So look, we have our y-intercept here because x is 0, and so this will be our y-intercept. Our slope in our or the line that it's perpendicular to is 1/2. So my new slope is going to be the opposite, which is negative, and then flip that fraction. It's going to be 2 over 1, which is just 2, negative 2. And then since I already have my y-intercept, I can just plug those in. I know my slope is negative 2. And then my y-intercept is 5. Alright, so really easy notes today. Make sure you fill out your note sheet and then submit it on to Canvas so I can give you a grade for it. See y'all in class.
Hanging with some cold killers, I ain't never back down or ran from no. I ain't sat down yet, I'm saying to go really. Even if I'm all alone, I'm saying it for